Okay, so we have our M&M's project DI that we need to be doing. All right. And what's our current class learning about? What's our current class learning about? Our current class learning is about surface area. And who can tell me how that learning is going to link in to this M&M's project? How is it going to link in, Jordan?
One is the right size for the M&Ms, like the right size shape for the M&Ms.
One is to find the right shape. Okay, find shape. Now, obviously this won't pick it up, but you know, is it that shape? Is it that shape for the M&Ms? Is it going to be that shape? Is it going to be that shape? There's this whole series of shapes that it could be. What this surface area project is doing for you is it's enabling you to see different shapes and think about that. How else is it going to help you? Isaac, how else is surface area going to help you with this M&M's project?
Know how many M&Ms fit and make it a bit easier.
Do you need to know surface area for what you're saying there?
That would be volume.
Yeah, so volume's a bit down the track. Okay. Volume, and what are you saying about volume?
Know the right amount of M&Ms to fit in the container.
Yeah, how much space maybe one M&M takes? Space of one M&M. Okay, and then when we've got the space of one M&M, Tani, what would we do?
Find out the space of the shape that you need to make.
No, just before that. We found out the volume of one M&M. What would we do after that, Lockie? Stay with it. Yep. We've got one M&M, the volume of one M&M. What would be our next step?
Find out the next elements.
Yeah, absolutely. So multiply it. Excellent. Good persistence. Multiply it. Don't know what that's doing. It's looking a bit ugly, isn't it? I'm not sure I'll go to that end of the screen, I don't think. Multiply it by how many you have, how many M&Ms you have. Okay, so what you'll have there, folks, is you'll have the total volume, won't you, of what your container needs to take up. Does that make sense? Let's get back to surface area for a second. What else is surface area going to help us with? Have a look at your project there, your project brief. You've got it in front of you, I hope. What are some other things that surface area is going to help us with?
It's going to help us find like how the size of the shape with the area of it.
The area of what?
Of your container.
The area of your container, Jordan?
The area inside the container, like you've got all the shape, the sides, and inside that.
Okay, so the inside, is that surface area or is the inside volume? Yeah, so you're talking about the inside amount. So we're still working with volume there. I'm still thinking back to surface area. So I'm thinking, folks, if I open one of these, I'm thinking that each one of these packets are yours. And what do you see on top? What are you screwing your nose up about, Damo? Isn't there enough M&Ms for you, mate? Even though you're giving them to her free. Luke.
The label, the nutritional facts and that.
Excellent. Labels, nutritional facts, logo. What else is there? Have a look, you people that have got them already, have a look.
Barcode.
Yeah.
what's in the actual
M&M.
M&Ms?
Barcode.
How much they weigh.
Weight.
The slogan.
Average piece of milk chocolate.
Ingredients.
The slogan.
Slogan. All of that. I'm going to click them in a while. Don't get too distracted with them. Remember, they don't melt in your hand. That was the original cell for them. So just pop them down for a sec, please. So you need to fit all of these things: labels, nutritional facts, logo, barcode, weight, ingredients, slogan. You need to fit all of that. Now that's going to take up a certain amount of space, isn't it? What do we call that certain amount of space? We call that area, yeah? And so your shape has to have a certain surface area for you to fit all of that on, doesn't it? For example, proposing that you use a triangular based prism for your shape. It's done it again. Proposing you use a triangular based prism for your shape. Okay? Now, if, for example, the logo that you access, very arty, just proposing that takes up 3 centimetres by 6 centimetres, therefore area equals length times width, 3 times 6 equals, just proposing that takes up 18 centimetres squared, yeah? One of these surfaces have to at least take up 18 centimetres squared, don't they? Alright, and then your ingredients will take up some room, and then your slogan will take up some room. And so your shape's surface area, or its total surface area, needs to equal all of these things at least, doesn't it? Plus, as you can see, you've got to put a picture of the actual product. Alright? What are the colours that appeal to the eye as you're walking down the shop aisle? Brown? All your bright colours, your red and all of that. What have they put them in lately? They've put them in yellow containers, haven't they? And they've put in blue M&Ms. It's a bit of a gimmick. Yeah? Bit of a gimmick to grab your eye. Where do they put M&Ms in the shopping centre? Right at the counter. What level? At eye level for me or eye level for my 5-year-old? Yeah. Not quite. Somewhere a bit in between. Okay, so folks, why are we doing surface area? We need to understand that surface area relates to the area of each surface of a shape. And when we're looking at a cylinder, for example, okay, you've got a surface there, and a curved surface, which if we unravel it, comes out to be a rectangle. Some of you have looked at that. Blue have definitely looked at that. And some are green, you're about to get into the cylinder area. Okay? You won't need to memorise those cylinder area formulas. They'll be given to you in a test, but you do need to be able to work with it. Okay? So under Google Images, if you type in M&M's logo, there's characters, etc., etc., you're going to be able to download those and start making your. You might choose to do a little creepy person like that, for example. But basically, what you're doing, you can see that there are thousands and thousands of M&M images. There's also some shapes in there and some ideas of what they're doing to try and sell more and more. You go back, you've got barcodes, even if you do that in total. Barcodes. Okay, so you can pick up barcodes easily enough. So there's just thousands of images there, okay? Basically what you're trying to do is you're trying to make the most appealing packet as possible. You'll save all of yours. Who's talking? You'll save all of yours I can print it out in colour for you. I know some of you may have access to colour at home, but I'm happy to do that here. Print it out in colour. You're making your net, okay? So if we go back to this part here, maybe there, yep. And I'll make a new page, and if I know how to make a new page, that'd be good. Yes, new page. All right, what are the step-by-step sort of processes we may go through with the construction? All right, we need to get this working. We need to play around with net constructions. Now, BLIUE particularly, your learning has been designed specifically so that you have been playing with nets, because remember, you're working on your own. Page 222 we'd be looking at there. Page 222, if I can bring that up quickly. Okay, so blue group and then green and red, you should be aware and observant of the fact that in the book on 222 there are some nets which may satisfy the constructions that you want, green and red. Alright, so there are some net constructions there. You've got the answers in the back of your book to work out which makes which shape, basically. Alright. So that'd be one thing, would be that you're going to play around with net constructions. How do I get the next page up again, do you remember? I'll just go with that. So we had net construction. You're going to play around with some of that. What else are you going to do with the net constructions or beyond the net constructions? What do you think some of your processes might be in order to solve this? So you've got your net construction. You've started to play with your construction of your net. You started to look at this. Let's think about, maybe if we can't think that far ahead, what class learning must we need to have before we can even get cracking on this? We definitely need the surface area stitched, okay? So class learning needs to be stitched at home as well as here. We're looking at surface area. Before that, we should have all our area formulas organised. All right, you should know your area formulas absolutely. Then we need to know our surface area. What else do we need to know? Our volume. Okay, need to know our volume of pretty much a sphere. Okay, M&Ms are pretty spherical in shape. They might be elliptical, all right, in which case you'd be looking for that. So you can see the importance of class learning, which is going to lead to your directed investigation and successful completion of your directed investigation. Remember, this is due in the last week, 4th of April, I think I gave on it. Okay, now if we look, it's the 20th of March now. So the class learning is imperative. It's imperative we work through that class learning, but not only work through it at pace, you know, actually get a meaningful understanding of it. And there's a difference between just doing sums checking at the back of the book and getting deep, meaningful understanding for it. All right, so that is your challenge that I'll put out to you today, is to really understand this learning as you go through, as I hope you're doing with everything. Are there any questions with this? Remember, you can refer back to this on YouTube. Can I explain that better for anyone? We'll revisit this. So this will be put up on YouTube as M&M's Directed Investigation Introduction, and then we'll do another one when we're a little bit more well versed with things like how do I work out the surface area and the volume of different shapes. Okay? Everyone okay with that?